Hello, my peeps. We will finish problem number 6 on page 94. And a little bit of a brain break for you. You got to do this on the EOC. He gone! In case you missed any of the Super Bowl, that would be Da Broncos channeling their inner Da Bears. Pick 6, baby. Take it to the house on the EOC, and you're guaranteed to get your $3.99 or higher.
Easiest is the second equation, 3 of C and A. So let's solve for C. If we want to get C by itself, what's keeping C from being by itself? This plus A. A is being added. So to get rid of it, we're going to subtract. We're going to subtract A from each side. So that gives us C. This positive A and the A cancel out. We have 100 minus A. Well, can we combine those? No, they're not like terms. So we write them separately. 100 minus A. So we have C equals to 100 minus A. C is equal to 100 minus A. Well, now what am I going to do with that value of C? I'm going to plug it into my first equation. Wherever I see a C, I'm going to put in 100 minus A. So let's write out our second equation. We have 326 is equal to $2.49 times C, number of pounds of cashews that you have. Well, the number of pounds of cashews you have is 100 minus the number of pounds of almonds you have. We have 100 minus A plus $3.89. Well, now let's see what we need to do. We see a parentheses here, so I know I'm going to distribute. I want to get rid of that parentheses. Let's see what I need to do. That gives us 326 is equal to, what is 249 times 100? $2.49 times 100. Well, multiplying by 100 is basically moving that decimal place over 2 places, so we get 249. So we did $2.49 times 100. That gave us 249. $2.49 times a negative A. A positive times a negative, we're going to get a negative 249. A by itself, that's really just a coefficient of 1. 249 times 1 gives us 249. So we have negative 249A plus, and there's an A right here that I forgot to write. You guys got to catch me on things like that. Plus $3.89 times A. Well, now we need to combine like terms. This is just like a solving for X problem. We need to combine our like terms. Well, both of these have an A, so we can combine them. We do $3.89. Clear that out. $3.89 minus $2.49 gives us 1.40A. Well, is that a positive or a negative? It's a positive. And we still have that 249. That is all equal to 326. Well, now I need to solve for A. Well, if I want A by itself, there's 249 right here. Is this positive or negative? It's positive, so what do we need to do to get rid of it? Well, since 249 is being added, we are going to subtract. We're going to subtract 249 from both sides of the equation. Let's see what that gives us. 326 minus 249. We get 77 is equal to what? Well, the 249 and the negative 249, those cancel out. We get $1.40A, 1.40 times A. We still need to get A by itself. We still need to figure out A, the total number of pounds of almonds that we have in the mixture. So I'm going to divide both sides of my equation by 1.40. Well, when I do that, my 1.40's cancel out. I get A by itself. We're going to take 77 divided by 1.4, and we get 55. We have 55 pounds of almonds in our mixture. Well, how many pounds of cashews do we have? Remember that the total number of pounds of nuts, so almonds plus cashews, that total number of pounds is 100. Well, if 55 of those pounds are almonds, then the rest are cashews. So if 100 total pounds of nuts, and we know that 55 pounds of it are almonds, what's left? The number of cashews. 100 minus our number of pounds of almonds is going to give us C, our total pounds of cashews. All we did here was take our equation, 100 equals C plus A, and solve for C. We did that by subtracting A, which was 55. So we do 100 minus 55, and we get C equals 45, because 100 minus 55 is equal to 45. So our delicious nut mixture here had 45 pounds of cashews in it and 55 pounds of almonds in it. Now, for a little extra challenge, I want you guys to think about this question as a typical mixture problem. So if you guys have done mixture problems before, attack this problem like that. You don't necessarily need to think about this problem with two different variables. Now, don't want to do it that way, you don't have to. You can still set it up as a systems of equation problem, just like we did here.